So yeah, let's zip through this one. So we want to try to fill in all that stuff. We can remember what most of that was, right? So what about symmetry test first of all? Symmetry test is this. We're going to evaluate the function at negative x and see if we either get back the original function f of x or the opposite of the original function, negative f of x. If one of those two things happens, that dictates if it's even or odd symmetry. If neither does, there's no symmetry. So here's our test for symmetry. F of negative x is what? Well, that would be, the first term is going to become negative 8 times the square root of 3x, isn't it? Everybody agree? Because I'm going to get a, here's my negative x. I'm going to get a negative x right there, okay? Plus 16 cosine of negative x. But think what cosine of negative x would do. Just look unit circle, right? Unit circle solves everything. If you look on the unit circle, that would be x, that would be negative x, right? Does the cosine change? Everybody agree? Because x is just the angle we're inputting into the function. Positive x would mean we're going to go counterclockwise from the x-axis. Negative would be going counterclockwise. Notice that they both have the same x-coordinate, so the cosine is the same regardless, right? So then what's this become? Well, this just becomes f of negative x equals negative 8 square root of 3x plus 16 cosine of x. The cosine of negative x is equal to the cosine of x. Okay? So then f of negative x is not f of x. So it's not even symmetry, right? F of negative x is not negative f of x. So it's not odd symmetry. It's neither. Okay. Make sense? That's our symmetry test. Evaluate the function at negative x and see what happens. Okay, let's do some derivatives. What's y prime?
Square root of 3 minus 16
Okay, and y double prime?
negative 16
Okay, so let's find our critical numbers. Is the first derivative undefined anywhere? No reason to be, right? That makes sense? Y prime is nowhere undefined because there's no danger zone, right? The only x appears inside a sine function and sine is well behaved. It's never undefined. So we're good, right? Okay, so then would you agree? We could say that y prime equals 0 when 16 sine x equals 8 radical 3. Agreed? Which is the same thing as saying sine x equals square root of 3 over 2. Okay, well, where in our domain from 0 to 2 pi is sine equal to the square root of 3 over 2? Isn't that happening there and there? Right? That's the big coordinate. Square root of 3 over 2 is the big unit circle coordinate. So that's going to be the biggest possible non-unitary, non-1 value of y. So that would be at that, what are those two angles? What's that angle? Pi thirds. And that one? 2/3 pi, yeah, right. Okay, so those are my critical numbers for the first derivative. Okay, how about the second derivative? Well, that's a pretty easy one, right? Y double prime equals 0, wherever cosine is 0. Where is cosine equal to 0 on our domain? Yeah, it can be right there and right there, right? So pi halves and 3/2 pi. Good. So now here's the thing, like building this table, what I would do on a problem like this is just go through and completely build the table, and then from there, just go back and answer all the questions, because you can get everything off of that table. So this is really a good exercise for us to go through here. All right, so let's make our table. Our domain goes from, we're including 0 and 2 pi. Our critical numbers, let's see, we had second derivative is 0 at pi halves and 3/2 pi. First derivative is 0 at pi thirds and 2/3 pi. And then we'll just figure out what's going on with all those. Oh. Okay, so these were zeros of the first derivative. These are zeros of the second derivative. So what do we do? How do we want to build this table? This is the key, is just knowing how to, this is what can save you a ton of time, is just getting really proficient at building these tables. So what number should we plug in where first, you suppose? No, there's not like one right answer, but
Plug in 0.
I mean, we can ultimately, but we don't necessarily need to start there.
Pi thirds.
Okay, what about pi thirds? I'm plugging it into what function?
Y double.
Exactly, right? I'm applying the second derivative test.
Yeah.
Okay, so we'll apply the second derivative test at pi thirds. Well, what is the value of the sine of my second derivative at pi thirds? Cosine of pi thirds is positive or negative? Positive. Times negative 16 is negative, right? Okay, so we've got a negative second derivative there. So what do we got? Horizontal tangent and
I'm frowning.
frowny face. So there's a relative minimum. Okay, where do we go next?
2 pi thirds.
Yeah, 2/3 pi. That's over in quadrant 2. Cosine's negative times negative 16 gives us positive.
So we have a point.
Okay, so that's positive. So we know we're going to get a minimum, right?
Yeah.
Okay, it also tells us what about x equals pi halves?
Point of inflection.
Yeah. That's an inflection point. Look at that. We got a lot done with 2 little points. Anything else we need to do? Well, yeah. There's really only one other interesting thing for us to do. We found all the the relative extrema, didn't we? Okay.
Yeah.
But where could we have another point of inflection? 3/2 pi. Okay. So why not just check at 2 pi? See what's going on at 2 pi, because that's part of our domain.
Okay.
So the second derivative at 2 pi is what? Positive or negative?
Positive.
The cosine's positive.
Yeah.
Times negative 16 would make the derivative negative. Okay, so then, yeah, look what we get. We get another inflection point right there, right?
Yeah.
And then what's left to do? Probably on this problem, I'm guessing they're going to want us to provide like ordered pairs, locations. So we want to go ahead and fill in the y row for all of these important points. Just evaluate the original function at each of those places, right? They're probably going to ask for that, so let's just do that. So our original function, let's just maybe copy that down again. So it's this here, I'm going to cheat. Legally cheat. Okay, so there's my function. Let's go ahead and evaluate this thing now. What's my function evaluated as 0? 16, right?
Yeah.
So we get a value here of, oops. We get a value here of 16. There's an ordered pair. How about at pi thirds? Cosine of pi thirds is, well, that's going to be kind of an ugly one, isn't it?
Yeah.
It's going to give us, we'll just make that a decimal. How about?
I think they want it non-decimal.
Are you sure?
That's what they told me last time I did this.
Okay, well, we can make it a non-decimal. So f, we'll just call this f of x. F of pi thirds is going to be 8 radical 3 times pi thirds. So that's going to be 8 square root of 3 pi over 3 plus 8, right? Cosine of pi thirds is 1/2. That's a pretty inconvenient value. But that's the number that's going to go right there. Okay? And if I evaluate the function at 2/3 pi, I'm just going to get both of those are going to become opposite terms. Right? No, they're not. That one's not. That one's going to be, never mind. I'm going to get, this one's going to be 16 square root of 3 pi over 3, and that's going to be plus 16 times negative 1/2, so minus 8. So that's the number that's going right there.
Wait, why is it?
That makes sense?
Oh, for 2.
For 2/3 pi. Yep.
Okay. Yeah.
Okay. At pi halves, that'll be an easy one. Pi halves, cosine of pi halves is 0, right? So pi halves, we're just going to get 4 radical 3 pi. At 3/2 pi, cosine of 3/2 pi is 0, but that's going to give us, what's that going to be? 4 times, so let's see, that's going to give us 2, so I get 4 times 3, so 12 radical 3 pi, is that what you guys got?
Why, where did
Okay,
the,
okay.
If I plug that in, I could have
when
made a
did you
mistake.
have the 16 stuff? Or some?
So I got
Where did it
I've
go?
got 3 pi over 2, so that gives me a 4. If I cancel the 8, right, I
Yeah.
get a 4 square root of 3 pi. Oh, that's it, isn't it? Just 4,
But then what happened to the second half?
and that goes to 0,
Done?
right? 3/2 pi, I think where that is, that's that cosine of 3/2 pi, that's on the y-axis, so that's going to have a, cosine's going to be 0 of that term.
Okay.
Right, because isn't that, I think where that is, right here, the x coordinate right there is 0.
Mhm.
Okay, so that should have, what did I say that should have been? I messed that up. That should have been 4. No, that's right. I think that is right, isn't it? I think it is. I think it's 12 radical 3 pi. Right, because I get a 4 4 out front when I cancel the 2 on the bottom times the square root of 3 times another 3 pi. So 12 radical 3 pi. Okay. And then at 2 pi, I'm going to get, that's going to be 1. And here I'm just going to get 16 radical 3 pi plus 16. Those are pretty inconvenient numbers. They really want those as, they don't want those as,
No, here, type your exact answer using pi.
ooh, yeah, those are kind of
Use
nasty.
integers or fractions.
Okay. So now we should be able to answer everything. So if we fill in these blanks too, like let's fill in, this is handy, let's fill in the y prime row. From our sketch, we don't even have to use a test point. What does the sign of the first derivative have to be to the left of pi thirds? Everybody see this? I feel like this is falling on deaf ears. Everybody get my question here? It's convenient for us to fill out this row because that's going to tell us increasing and decreasing intervals. Okay. What is that, a plus or a minus there?
Wait, where?
Right here.
Negative.
You can tell by the shape, right? It's a peak.
Down.
It's got to be increasing on this side, right? Because the function in amp would be walking uphill towards that peak. Agreed?
Yep.
So that's got to be plus, and that's got to be minus, because that's what the first derivative tells us. A minimum is a place where you're transitioning from positive to negative first derivative. Okay, what's got to be to the right of this, or maximum, sorry. What's got to be to the right of this minimum? Positive. That's got to be a positive first derivative. And so now we've got everything, right? What's that telling us? Well, this tells us increasing on this positive interval and this positive interval, decreasing on this negative interval. Concavity is determined by the sign of the second derivative, so it's concave down on this negative second derivative interval and this negative second derivative interval. And it's concave up on this positive second derivative interval. So everything we need, we can now take from that picture, all of it. Okay? Just a matter of filling in the blanks. Okay, so if we've got all this stuff, I'm going to pull up the question and let's just look at the question. Okay, so should we just go through and answer this here? So the domain is, well, it tells us interval notation. So I just get bracket 0, 2 pi. Oops. bracket. Check. Fantastic, it tells me. Symmetries function we decided is neither even nor odd, right?
Yeah.
Okay. From our symmetry test. First derivative, what do we get for first derivative? Got to go up a little bit for that. Okay. First derivative is 8. Oh, doesn't do that trick. 8 square root 3 minus 16. Oh my gosh. Sine x. Okay. Everybody buy that? Okay. Oh, another fantastic. Second derivative was negative 16 cosine x. Okay, excellent that time. Critical points occur at what x values? What did we say? Pi thirds and 2/3 pi? How come we can't see that stuff? Pi thirds, comma, 2 pi thirds. Excellent again. Local minima. Type in ordered pair. Okay, we had local minima right there. Okay, ooh, that was an ugly one. So the ordered pair was 2/3 pi and then it was that bottom bubble. So 16 square root of 3 pi outside of the radical divided by 3. Oh, we can leave it like that. But how about if we make it look prettier? I'll take that and put it up here.
Oh my. I got it wrong too.
Minus 8.
Oh, I forgot.
Okay. Oh, what the heck?
Oh my.
Local minimum.
I just got it wrong, so I'm gonna restart.
Okay, I'm kind of hating this problem now too. What the heck did we do wrong there?
I don't know.
Okay, if we plug in 2/3 pi, that gives us 16 square root of 3 pi over 3. Okay, good. Plus 16 times negative 1/2. That's minus 8. Hmm.
What?
I got that one right. But mine is different numbers.
Me too. Mine is
And
two.
mine
I still
is
got it
slightly
wrong, so.
different.
Oh. No, I don't get it.
Let's just do it wrong.
I think that should be right.
Let's just throw it out.
I think it should too.
It's, wait, go back to it. Wait, pull up that assignment again. Pull up the 16. Oh, you're missing the first points, the 0, 16.
Oh, okay. Oh, okay.
Yeah, they want the first point too.
Okay, that is not good.
Bless Aubrey.
That's not a critical point.
Oh, you're not doing critical points anymore. doing the minimum, right?
Oh, local minimum though.
Yeah, they're counting the endpoints.
Okay.
Well.
Okay, so this one,
I
okay.
told you that before I got
So
it.
this one counts endpoints as local minima. Remember, we kind of decided we
Yeah.
weren't going to do that. Okay, but we'll,
Yeah, this is toxic. Honestly.
okay. So I'm going to make a note on this one that reminds you then. I can put a little reminder.
Let's do this.
Okay, whoops.
Oh.
Okay, so that's, I got you. So then they're going to treat the other endpoint as a maximum.
Yeah, I think
Yeah.
so.
Okay. So then, okay. Again, I disagree with that.
Me too.
I do too.
I think we all have issues with that.
Obviously, on a test, you get
It's
full credit
enclave
for that.
open's the minimum, right? Or am I thinking of it backwards?
Eight square root of 3 pi divided by 3
Oh wow. Okay.
plus 8, okay, comma 2 pi. Oh my gosh.
Okay. How do I read? Oh, garbage.
16 square root
How do
of
I know where
3
my local minimum maximum are? Because I don't like know how to do
pi plus 16.
How do I know where my stuff is? When I don't
Okay,
know
check answer. Excellent. That is pretty rewarding when it gives you the excellent after typing all that stuff in there.
What?
Okay,
It's also
identify
really frustrating
where
when
the
I
curve
do
is
wrong.
increasing or decreasing. Okay, so what's the first interval where it's increasing?
From 0 to pi thirds.
Okay, and I would not include brackets there, right?
No.
I'd have to go 0,
What the heck?
comma, pi thirds. Okay, and then I'm gonna get out of, oh, you guys can't see that, can you? 0, you didn't get to exult in the last time we got a green check then either.
No.
0 pi thirds. Okay, I'm going to go out and make another comma, another interval, and where's the rest of it? It's increasing also from 2/3 pi to 2 pi.
Okay. So 3.5 pi. Where are the maximums, guys?
Okay, check. What?
Oh my god. Oh no. Wait. Because you didn't do the decreasing.
Oh, do I have to do both parts of that?
Oh, you put does not decrease.
Oh, I got you. I put it in the wrong spot. I got you. So I got to delete that. Put it increasing there, decreasing pi thirds to 2/3 pi. Ooh, I'm going to cut and paste here.
Oh, it's these two.
Copy. Oh, look at that. Cutting and pasting.
Wait, what is it? It is. This is why I'm so busy. Zero.
Okay. There it is. And then finally, inflection points. We had inflection points at 2 of them. Pi halves 4 radical 3 pi.
Oh my gosh. What the heck? just gonna wait for you to get here. I didn't even
Three,
have to
yeah.
do-
There's
I thought-
another question.
But like, oh my gosh, I'm only on part 10
So I
of
should have
16. This is crazy.
Wait, yeah, no, I'm stuck. Did you get this one right?
Where you at?
10, part 10. I keep getting it wrong. And I only have one more try, so
If I
I
make it this
I need
far
your
in this
help.
problem,
and I scrub now.
and I don't, oh my gosh,
Well, I literally made it 2 parts in, and it won't let me skip. I have to go through every single problem.
What?
Type 0.
Oh, I didn't put the other.
I know, I hate doing
I gotta put the other. There we go.
that. Okay, I need help with the next part.
Okay, fantastic. Concave up, concave down. Okay, this does take a little while, huh?
Cause I don't know what it is.
Check answer. And there's 5.
Help me.
Yes!
What's the answer?
Concave up between
Oh my gosh.
pi halves, 3/2 pi.
I don't think I have my table folded right.
I have some 3/2 pie.
No.
Mine is
yeah, because he's all of these mine.
concave up between pi halves and 3/2 pi, right? Between the zeros of the second derivative.
0.
Oh, we can include 0.
This is the second
Wait, so
So when is it concave down?
wait, so
Concave down, so it's concave down wherever the second derivative is negative. So on that negative interval there, and that negative interval there.
So
So 0 to pi halves or 3/2 pi to 2 pi is where it's concave down.
0 to pi.
Yeah, you have to do both, right?
0 to pi halves. Wait, 0 to pi halves and then
3/2 pi to 2 pi.
3/2 pi to 2 pi.
Yep.
This better be right.
Oh, guaranteed.
yay, you're right. Oh, there's more.
3.
Okay,
Wait.
Grace, you keep saying there's more, acting like there's not 16
Okay, I know,
parts.
but like,
Yes. Okay. It doesn't have any more
Dust.
glass, right?
Right.
Oh, it doesn't?
No,
How
it
did you
doesn't.
know that?
Because I got it wrong with the last round.
Okay, it doesn't have vertical asymptotes because there's no place where we'd have a 0 in the bottom of our function, but not the top, right? There's no unique zeros of the denominator.
Two,
What is an oblique asymptote?
is this slanted?
Oh,
Comma.
maybe.
I'm using my graphic calculator on this number. 2, comma.
The absolute. Is the absolute, that's when we're not counting the endpoints, yeah?
Okay, that does. Absolute includes endpoints
Absolute
too.
includes the endpoints?
Yeah. Horizontal asymptotes,
Wait, but
none.
There's such funky numbers, I don't know which one is the absolute.
Yeah.
This is where you would just plug them in a calculator.
Oh.
Okay. Yeah, cheap.
Okay, graph of our function. Which one would it be? So we got
Increasing.
maximum, minimum, point of
Yes.
inflection.
Yeah.
So
Do which part?
Absolute maximum, I guess.
Absolute maximum, I just did what 2 pi was. So I put the y in and then x is 2 pi.
so it's got to be b because at 0, the value of the function is not 0. So it's got to be b.
Yeah, x equals 0.
Okay.
Because that's where the highest point is. If you look on the graph, Grace.
Yeah, you can look at the graph
Here's
now.
the graph, and obviously 2 pi is going to be the highest point.
Highest points at the right end point, lowest points left end point.
The minimum's going to be at 0.
Yep.
I did it. Thank you.
Okay, I'm stuck on part 8.
Part
Okay,
eight.
maximum.
Okay, I've officially conquered the problem.
Yay. That was so satisfying.
wow, I did that, now I'm at 50%.
Yeah, it's an important problem.
Okay, whoa.
How do you do?
I'm just gonna
Now we
cut.
just have to
Can you
do
cut and
more.
paste? Like, can I go up and grab this stuff and
No.
you can't? It doesn't let you do that.
Uh-uh.
Oh, that's unfortunate.
I know.
I don't know how you do it.
16 radical 3 pi plus 16.
Curve increases. When numbers 8. My
Curves at x equals 2
You guys see
pi.
I got stuck.
Let's go.
Bingo.
The curve
Absolute
increases.
minimum value of 16. Curves
And you're
at
done.
0.
To my thirds.
Uh-huh.
Ouch.